PHPP and overheating. What is the PHPP? It's the Passive House planning package developed by the Passive House Institute. It's verified and accredited by the Institute. And it's basically building science in an organized format for the benefit of the whole team. It's used as a design tool, and it's used by Passive House designers to determine the performance of the building in accordance with Passive House criteria, regardless of whether you choose to actually certify the Passive House. It's a really useful tool for making sure holistically that your building performs in all aspects. It includes climate considerations, orientation, context, U values, surface areas, as in the thermal envelope on all three dimensions, components, windows, glazing, doors, reveals, shading, ventilation in the winter and the summer, heating and domestic hot water, internal heat gains, electricity use, and its performance guaranteed in terms of the accreditation from the Institute. Why use PHPP? Why not just do an eco home or nearly passive home without using the PHPP? The outcome for the performance of the building may be fragmented and unreliable. It may overheat. The site in context may not be modelled. The orientation shading might be incorrect. It might be overspecified. We might think we need more kit or renewables than we do. It might not have enough fresh air, or it might have too much, causing dry atmosphere. It may not have been stress tested for future climate scenarios. The PHPP ensures that the building does what it says on the tin. When I talk about climate, in the UK we have site-specific climate data broken down into regions of the United Kingdom. We also have consideration for the exposure, and we also have future stress testing for anticipated changes, rises in temperature in the future. And these all together with the attitude considered give us an overall climate site-specific model. We also like to consider orientation and site context. In other words, which way does the building face? Which is the best views versus the best use of the building to gain solar thermal gain? We like to think about noise and interference from the outside. Consider the sun path, what happens to the building in the winter and in the summer. And also, of course, security and privacy, depending on the use of the building. When we put all the thermal envelope together, the surface area of the buildings, we talk a lot about the U values, and indeed the Passive House Institute asks for certain levels of U value in order to achieve a passive house. Once again, this is site-specific, but perhaps this is a little bit of an insight into some of the science. When we talk about E values, we talk about a formula which is based on the resistance of the air outside and inside, and of each product within the build-up of the fabric of the building. It's a formula that's used all the time when one looks at products. They're quite often claimed to have a U value, but as you can see even by this situation, depending on how the building is working, which is the heated area, what the exposure is, these figures will change. The RSI and the RSE will change constantly according to that situation, and therefore giving us a U value for the performance without considering the actual specific use and location of a product is quite unreliable. We prefer to use what we call the lambda value, which is the thermal conductivity. The lambda value gives us a specific thermal conductivity of every product in the build-up of the fabric of the building. And then you put all those sandwiches of lambda together and we come out with a U value that's specific to the project. The resistance of this build-up is basically the thickness of each piece. So the insulation, for example, 50 millibit insulation converted into meters divided by the lambda will give you the thermal resistance of the product, which then goes into the U value inverted with the RSI in the answer, or E, depending on whose figures you're taking. So that's a very quick overview, but it is component and context specific. And therefore, if we go back to the original sum, the original formula, the lambda, we're able to ensure that the U value outcome is actually accurate to the situation we're looking at. So when you go to purchase insulation, for example, for a project, and they say, oh, well, this insulation is the same insulation, it may not have the same lambda. By not having the same lambda, you have a knock-on impact on the thermal performance of the building. So the figures that you're given for the lambdas are actually very important in ascertaining that the performance of the building is as we've designed it.